Hi everyone, welcome back to Calculus with Jackie and Shadow. Today we're going to be talking about derivatives. We're starting our new unit, and we're going to be starting with the concept of instantaneous rate of change. So to start out with, if you look at this line that I have pulled up on the graph right here, what would you say the slope of this line is? Well, assuming I have the window zoomed in to scale, it looks like it's going right one box and up two boxes. So you can say that the slope of the line is 2. But what if I told you that this is not a line? Let me zoom out here. It's not a line, it's a curve. And this is kind of a new concept, finding the slope of a curve. But it's what a lot of calculus is based on. So you've done this in algebra with finding the slope of a line. So if we have 6x plus 7, 5x plus 31, they have a slope of 6. This one has a slope of 5. But it's possible to find the slope of a function that's not a straight line. That's where the calculus comes in. Basically, what we want to do is take an average rate of change and use a limit to bring the 2 points you're measuring it between closer and closer together. So if you have delta y over delta x, you want that change in y and change in x to get really, really small. And let's do a quick review over the limit notation, how you can do this with limit notation. So I'm going to let you try this for yourself. What would the limit notation of the instantaneous rate of change be for this? 1. Jackie is flying on the graph of some function f of x. The slope of the graph is estimated at a point by finding Jackie's coordinates at 2 points, x1, y1, and x2, y2. And these points are very close together, so it's getting closer and closer to the actual slope. Well, we're going to want to take a limit. In this case, the limit is x2 approaches x1 of y2 minus y1 over x2 minus x1. Next example is Shadow is flying on the graph of some function g of x. The slope of the graph at x equals a is estimated from his y position at x equals a and at x equals a plus h. In this case, we want the two values to get closer and closer together. So we have a plus h and a. We want h to approach 0. And change in y over change in x is going to be g of a plus h minus g of a over h. Now, Sunny is flying up at some angle, and her rate of ascension is estimated at some point by using a small change in her x position and a small change in her y position. When you see small change in x, small change in y, you want to think delta y over delta x, and we're taking the limit as delta x approaches 0. And finally, Gizmo's distance traveled as a function of time is x of t. Her velocity is estimated by finding x of t1 and x of t2, where t1 and t2 are very close together. The change in y is going to be x of t2 minus x of t1, and the difference in x is t2 minus t1. So to find the velocity, we're taking the limit as t2 approaches t1 of this. Now let's try our first actual problem using this technique. So Spirit's flight is represented by the function x of t equals 2t squared minus 4t plus 1, where t is time in seconds and x of t is distance traveled in meters. What is our velocity at t equals 3? Well, we're going to want to create our change in y and our change in x. And for that, we need the x2, x1, y2, and y1. In this case, x2 is going to be 3 plus h, and x1 is going to be 3. And if you have x2 minus x1, it's just going to be h. And if you have this up here, we have 2 times 3 plus h squared minus 4, 3 plus h plus 1, and minus 2 times 3 squared minus 4 times 3 plus 1. Now we can cancel some of these out. So we can cancel out the plus 1 from both sides because it is subtracted on this and added here. And then this numbers, we can evaluate these. So this is going to be 18 minus 12, which is 6. And now we can start with this side as well. So minus 4 times 3 plus h is going to evaluate out to 12 minus 4h. And then this 3 plus h squared times 2, we can expand out that polynomial, and we'll get 9 plus 6h plus h squared. Multiply out by the 2, and we get 18 plus 12h plus 2h squared. Now we can cancel even more of these out. The 18 minus 12, that becomes a plus 6. And that cancels out with the minus 6. And then 12h minus 4h, that becomes 8h. And we're left with 8h plus 2h squared over h. And at h equals 0, this is undefined, but we want to find what this is getting closer to as h gets really, really close to 0. So we can do the sum of the quotient flyer and cancel out terms. We can factor it out in h in the numerator and the denominator, and we get our final expression, which is 8 plus 2h. We're taking the limit as h approaches 0. And this 2h is going to go to 0, so we're left with 8. Spirit's velocity is going to be 8 meters per second at t equals 3. So that's it for today, and I'll see you next time.